Hey, this is Buzz signing in with episode 12, part 2. And you'll have to excuse my voice. I've got an upper respiratory infection that I'm battling, but what we're doing here in part 2 of episode 12 is finishing the assembly of the M400 Starduster antenna. And on the floor here, I've got the vertical radiator laying out with a tape measure next to it. And the reason for that is we need to set the length of the radiator to match the resonant frequency that I'll be tuning it for. I've decided to tune it to the center frequency of its range, which is 26.5 to 30 megahertz. The center frequency is 28.25 megahertz. And the instructions come with tuning instructions, and there's a graph on here with the X and Y axis, and basically it says that the radiator, to be resonant at 28.25 megahertz, needs to be 2,527 millimeters in length. So I did the math. That comes out to 99.6 inches. Okay, and in case you want to write this down, if you need to do this in the future, 1 millimeter is equal to 0.0394 inches. So you just take your length of millimeter, multiply it times that coefficient, and that'll give you the length in inches that your radiator needs to be. Another thing that you might want to note, as frequencies go higher, the wavelength gets shorter. So if I had wanted to tune this, say this antenna all the way up to its upper end, 30 megahertz, it would have been 2,421 millimeters instead of the 2,527. So it would have been a shorter here. But basically, the point I'm tuning it at, the radiator is about half of what it would be if you tuned it all the way down at the bottom end, 26.5 megahertz. But enough of that. Okay, so we see I got the tape measure stretched out. I've already got it set to the 99.6 inches in length. Right there in the center where you have the three little radials coming out, that's your point where the two pieces come together. There's a set screw. Make sure you set that screw very tightly, because you don't want to get it up in the air and then have it moving around on you and then it's out of tune. So next what I'm going to do is show you the base section with its three radiators. Because I'm still in the house, we're still having some bad weather, I can't get it outside, so I have not set the length on those yet, but it will be the same thing. They'll need to be 99.6 inches in length, and then we'll get it outside, get the whole thing put together and mount it on a mast. Okay, now here is the base part of the antenna. Of course, that top radiator that I just showed you will screw into the base section there, which is the end closest to the camera. And once we've got that all assembled, again, the radiators on the base here, I have not set those yet, the length, but they will need to be the same as the center radiator, which in my case was the 99.6 inches. So we'll get those two sections screwed together. You can see it's going to be pretty tall. The whole antenna is going to be probably somewhere, well, be well over 10 feet tall altogether. So it does need to be assembled outside. Once we'll do that, something else I've decided to do, I watched a YouTube video, and you might want to check this out. There's a channel, the guy calls his channel DB, like Delta Bravo. And he's got a computer modeling program on there where you can put the type of antenna you have in it, and you can change it around, change the angle of the ground plane, and it will tell you what the dB gain of the antenna is. Now on an antenna like this, which is a quarter wave ground plane, the dB gain is not as inherently as good as a dipole antenna. But what I saw from watching this video, where he gradually changed the angle of those ground planes, as the steeper the angle, the more the gain of the antenna increased. And he says that it was because the more they become vertical rather than horizontal, it starts acting more like a dipole antenna. Another thing that I thought was interesting in this video was that in the model he had the antenna as if it were floating in free space. There was no mast underneath it. And this model gave it the most dB gain. Once he added a mast pole under it, the gain actually decreased for the antenna. Of course, a dipole antenna has no mast pole. It's not grounded to the earth. So what I've decided to do is I'm going to isolate the antenna from the mast pole. The mast pole is metal, but I've got some rigid PVC pipe, conduit actually, electrical conduit pipe, that I'm going to mount the antenna on, so it's isolated from the mast, which would give it the same effect as if it were free floating in space. And I'm just curious to see how that's going to work out. But if you decide to do this yourself, and of course later on I'll let you know how well that worked out, what you need to be aware of is that base needs a 1.5 inch mast pole. That's the maximum that you can have, and that's the outside diameter of the pole, not the inside. Okay. The electrical conduit, which is the gray PVC conduit, is what I chose to use mainly because it's weather resistant as opposed to the white PVC, and it is electrical conduits what it's rated for. So I thought that would be a better choice, plus the color matches the pole better and everything. But yeah, I originally bought a 1.5 inch diameter, and it was too big. That's because that 1.5 was actually the inside diameter of the conduit. So I went back and got a 1.25 inch, and it fits snug in there. Okay, so later on in the video you'll see that when that's all put together. So stand by and we'll move on to the next phase.